let's try example 2. Example 2 is the same question as example 1, but I have to do trapezoidal rule and Simpson's rule. So example 2 says approximate the definite integral using the trapezoidal rule and with Simpson's rule with n equals 4. So I have to do this problem twice. I have to do it once with trapezoidal rule, this formula from this page, and then once with Simpson's rule. And because they're both estimating the same area, they should be really close. Trapezoidal rule is using trapezoids. Simpson's rule is actually just, it's a trapezoid with a kind of a curved top to fit the curve a little bit better. So Simpson's rule is supposed to be a little bit better, but we're just gonna use them both and see what we end up with. So I will kind of be going back and forth looking at my formulas and doing my best. So I'm first doing the trapezoidal rule, and the trapezoidal rule says b minus a, so 1 minus 0, over 2 times n, and in this case it says n is 4. And then it says f of x sub 0. So in this case, you know, we're going from 0 to 1. So to give you a visual, you know, we're starting at 0, we're ending at 1, and I have to have 4 like trapezoids in there, so this has to be split up equally into 4 parts. So halfway would be 0.5, half of that would be 0.25, and half here would be 0.75. So 1, 2, 3, 4. 4 equal trapezoids, so it looks like those are going to be my trapezoidal endpoints. This is the left-hand side, this is the right-hand side, and these are all the middles. So when I do this, I'm going to have to do f of 0 plus 2 times f of 0.25 plus 2 times f of 0.5 plus 2 times f of 0.75 plus f of 1. Again, f of 0 and f of 1 have no coefficient, and then all the middle numbers get that times by 2. Again, it's because those are used twice when making the trapezoids. So here we go. Here on the top we have 1 minus 0, which is 1. 1 divided by 8, so the fraction out in front ends up being 1/8. And then f of 0, where do you get f of 0? My function is just this right here. I don't have to do the antiderivative. The whole point of the trapezoidal rule is to use it, oops, I'm sorry, that should be an x. The whole point of the trapezoidal rule is to use it when you can't find the antiderivative and actually do the problem. So you don't have to do the antiderivative or anything to this. You just take it as is and just start plugging the numbers into that. So f of 0 is going to be square root of 0 times square root of 1 minus 0. So square root of 0 is 0, and 0 times anything is 0. So f of 0 is 0 plus. Now I'll do f of 0.25. And so I'm going to do square root of 0.25 times square root of 1 minus 0.25. And I'll show you what I'm doing. So square root of 0.25 times square root of 1 minus 0.25, and that is 0.433. Just, okay, so then that's 2 times 0.433 plus. Now I need 2 times f of 0.5, so I need f of 0.5. So square root of 0.5 and square root of 1 minus 0.5. Got to get that on here. Second enter. Go back. And that's just a plain old 0.5. Great. So then that will be 2 times 0.5 plus 2 times f of 0.75. So I have to get f of 0.75. Square root of 0.75 times square root of 1 minus 0.75. Got got it, and it is 0.433 again. So I have f of 0, f of 0.25, f of 0.5, f of 0.75, and now I'm down to f of 1. So f of 1 is square root of 1 minus square root of 1 minus 1, 1 minus 1, oh, that's times, sorry. Square root of 1 times square root of 1 minus 1. 1 minus 1 is 0, square root of 0 is 0, 0 times anything is 0, so this last one ends up being 0. Now I'm just going to take my calculator, type all of that in, and see what I end up with. So 1/8 times, don't need the 0, so 2 times 0.433 plus 2 times 0.5 plus 2 times 0.433, don't need the 0, and with that I ended up with 0.3415. That's my trapezoidal approximation.